The chairman of this session is Dr. P.K. Jain. Dr. P.K. Jain is Chief Scientist, CSIR, Central Road Research Institute. He is coordinator of CSIR, Academy of Scientific and Innovative Research, head Flexible Pavements and Secretary Research Council. He is the member of IRC committees H2, H4, S6 and accreditation of new materials. He is member of BIS committees. He has drafted many IRC codes and BIS standards. He is author of more than 125 technical papers. May I now request the chairman to kindly conduct this session. Dr. P.K. Jain.
Me, Mr. T.K. Amla, Head of Information Liaison and Training Division, co-chairman of the session. Good morning, everybody. This session on journal report on road research is one of the important session in all IRC annual sessions. And as we know, research is highly important not only for highway sector but for overall development of the country. This session is divided in 4 parts. The part 1 is pertaining to road research, research work done in the area of pavement engineering and materials. The part 2 deals with research work done in geotechnical engineering. Part 3 deals with bridge engineering and traffic and transportation engineering. And there are some research presentations in second part of the session. As we know, nation is facing acute shortage of aggregate and other pavement materials. Researchers have to provide alternative solutions. The use of RAP, waste materials, technologies for reduction of thickness, technologies for use of alternate materials, waste materials and alternate designs are necessary so that pavement materials for the future can be saved. The thrust area of the research in 12th plan should be focused on these aspects. Now I request first presenter Shri Vinod Kumar. Shri Vinod Kumar is going to make presentation on the road research work done in the country on the area of pavement materials and engineering. He is a senior scientist at Central Road Research Institute, Rigid Pavement Division. He has done a lot of research work pertaining to materials and pavement design pertaining to rigid pavements. He has a long experience. He has done a lot of consultancy projects in the area and solved many problems. Now I request him to make the presentation on the research work done in the area of pavement materials and engineering. He is given 15 minutes. I request him to finish his presentation in about 15 minutes. Now I request Vinod Kumar to start his presentation.
Respected Chairman, Co-Chairman and fellow delegates, when it comes to the research in the area of pavement engineering materials, the need of the hour is to develop such materials and innovative techniques in design and construction of the pavements, which may lead us to conservation of natural resources, thinner and long-lasting pavements, low energy consumption during construction, and overall sustainable development in the road sector. The projects which have been reported in this chapter 1 suggests that we are moving in the right direction. I will be presenting all the R&D projects which have been reported in flexible pavements, rigid pavements and pavement evaluation area. First, flexible pavements. 7 numbers of projects have been reported for the first time, 9 are either ongoing or completed, and overall 16 projects have been reported this time in flexible pavements. First, development of low energy, that means warm asphalt, PMB and CRMB mixes. Objective is development and mechanistic characterization of low energy PMB and CRMB mixes. Interim findings reported are that with 2% warm mix additive, polymer modified bitumen mixes can be laid and compacted at lower temperature. Warm PMB mixes have lesser rutting and higher creep recovery at higher temperature. Overall better performance than traditional hot modified mixes and energy savings. Next, study on use of emulsion based warm mix asphalt using half warm aggregates for bituminous road construction. Objective of this R&D project is to investigate performance of emulsion based half warm mixes. Test sections have been laid near Gondal in Gujarat on NS27, and it has been found out that rutting resistance, indirect tensile strength ratio, resilient modulus are acceptable and identical to traditional HMA mixes. Warm mix asphalt mixtures can be prepared and laid with conventional construction equipment. These are the photographs relating to the laying of preparation of the mixes and laying of the test section in Rajkot on NS27. Next reported project is studies on use of reclaimed asphalt pavement wrap in construction and maintenance of roads. Interim findings of these projects are that wrap is usable in different pavement layers depending upon its quality. Foam bitumen, emulsion and petroleum products can be used for the rejuvenation of RAP mixes. Next, these are the photographs of wrap at sections where it has been laid. Next project have been reported as verification of flexible pavement design methods, that is IRC 37, using heavy vehicle simulators, which is available in CRRI. Objective is to verify the recommendations of IRC 37 by testing the test sections with heavy vehicle simulators APTE in CRRI. Test sections have been laid in CRRI campus and have been tested using APTE. Interim findings is that pavement response in terms of calculated vertical strain is comparable with IRC rating models. That means whatever strains have been observed during the test section performance, they are in agreement with the IRC rating model. Overall physical response is exhibiting consolidated rating phenomena. Next have been reported as, these are the photographs of heavy vehicle facility simulators or APTE which exists in CRI campus, and the lower photograph shows the rutting which has occurred after the repetitive loading of the test section. Next project reported is development of improved materials, mixes and design methods achieving reduced pavement thickness. And interim findings are, if you use polymer modified binders, it will not only help improve tensile strength, martial stability, rut resistance and resistance to fatigue failure of the bituminous mixes, but it also helps in reducing the overall pavement thickness. Stabilized bases are another option which can be used to reduce the overall pavement thickness. Next is study on the use of waste plastic for road construction in urban areas. Under this project, waste plastic coated aggregates have been used for the bituminous mixes, and it has been observed that when you use plastic coated aggregates, then the binder requirement goes down, and we observe the increase in stability for all DBM, BC and SDBC mixes, and no stripping takes place even after 72 hours of water soaking. Next is application of nanotechnology in road construction, a pilot study in Leh. Yesterday we have seen a presentation from Zydex Industries, and the same materials have been reported in 2-3 projects. It has been tested. This was tested in a test section in Leh, and findings have indicated that laying and compaction was better. There was no sticking of the material to the roller when you use Gypsum as an additive to the bitumen. Mix can be easily mixed, and there is a uniform coating of the aggregates, better bonding and improved stability of the mixes, and stripping value have been observed less than 10%. This is another project which have been reported using the same Gypsum materials, nanotechnology in road construction. And it has been observed that when Gypsum is used in bitumen for prime coat, tack coat and seal coat, then at the rate of 0.1%, then it results in better compaction, faster setting and impervious bituminous surface. Again, the next have been used, Gypsum have been used in various combinations. 3 test sections under this project of nanotechnology based multi-layer waterproofing treatment of soil and asphalt concrete in road construction. 3 different test sections were laid. Control sections didn't have any Gypsum in any layer. Then second test section had Gypsum in subgrade, and the third test section Gypsum was used in subgrade in prime coat, seal coat, tack coat and bituminous mixes. It has been observed that untreated section where there was no Gypsum, post-monsoon cracking and potholes were observed. But in those sections where Gypsum was used, it was observed that small potholes after monsoons were observed where Gypsum was used only in subgrade. But when Gypsum was used in all the layers, then it was observed that there was no distress on those test sections. That means Gypsum is proved to be a wonderful material, as the findings of these projects have suggested. Next is use of laterite stone in road construction. Objective of this study is to study the use of locally available laterite stone aggregate in the place of trap basalt for BBM layers. Test sections have been laid in Kapadgaon to Joshiwadi and Maseba village in Maharashtra. First section was laid on existing WM surface, and the second test section was laid on existing BT surface. And it was observed that in the pre and post monsoon observations have to be taken for the 3 years, and interim findings are awaited for this project. Next project reported is study to prevent reflection cracking on bituminous overlays over cracked concrete concrete pavement using geotextile. You see, whenever a bituminous overlay is placed over existing concrete surface, then joints are reflected into the overlay. Geotextile has been used to minimize those reflection crackings under this project, and it has been observed that bituminous overlay with geotextiles gives better performance, and they mitigate the occurrence of reflection cracking in bituminous layers whenever placed over existing concrete pavements. Next is resource mapping of road construction materials in Kerala, Thiruvananthapuram district. Under this project, whatever material is available in Thiruvananthapuram districts, it has to be characterized, and all the data relating to its properties of the like specific gravity, water absorption, AIV values, elongation, flakiness, all these data have to be prepared on a GIS platform so that it can be readily accessible and usable by the users. Findings says that these local available materials is fine for all other properties, but combined elongation and flakiness index requirement as per the MORTH is not fulfilled, and that's why researchers have asked that in case of locally available material, MORTH guidelines should be relaxed so that they can be used at local levels. Now come to the R&D projects which have been reported in rigid pavement sections. First time reported only 3 projects. nothing is ongoing or completed. This is really a matter of concern for all of us, because the future of Indian roads belongs to the concrete pavements, and we need to carry out more and more research in concrete material and as well as in concrete pavements. So I hope we all will take note of this. Whatever projects have been investigated is investigation of causes of longitudinal cracking in concrete pavements on national highways. Something which do not crack is not concrete. In fact, during construction, we help concrete to crack by sawing the joints. We design concrete pavements in such a way that full depth transverse cracking will occur in the middle of the slabs near the expiry of its design life, that is 25 to 30 years. But in the last 8-10 years, whatever concrete pavement sections have been laid on national highways, many of them have shown premature longitudinal cracking in the outer lane. And a project has been taken to investigate what are the reasons for this cracking. There are few known reasons, but there may be some unknown reasons as well, which are particular responsible for the Indian conditions. Interim findings, whatever work has been carried out so far, says that longitudinal socket joints between outer lane and shoulder have not developed crack under it. It should have happened, because that is the purpose of sawing the joints. Since the joints has not occurred into the, you can see these socket joints, core is showing the socket joints, and there is no crack under this. And this could be one of the reasons that crack is taking place in the middle of the outer lane. And this has happened at all the sides. So we are putting a joint between shoulder and outer lane. We have to think about it, whether it is workable or whether we should go for the deeper socket depths at these longitudinal joints so that crack happens. Normally it is 1/3 to 1/4, but I feel that we need to increase the depth of socket in case of longitudinal joints. In case of transverse joints, it is fine. Next project observed is utilization of waste foundry sand in place in pavement quality concrete. Waste foundry sand is a waste product of all foundry industries. It is a very fine sand, and when it has been used into the pavement quality concrete mixes, and it was observed that because of the higher fineness of this sand, water demand of the mix go on increasing, and if you go on increasing the water into the mix, water cement ratio will be high and downfall in the strength have been observed. But up to the 20% replacement of natural sand by foundry sand, we can modify the mix so that whatever increase in water demand is there, it will not lead to any downfall of the compressive and flexural sand. That is manageable up to 20%, but beyond that it is difficult. Next is calcium sulphate derived from ternary flashings for use in cement formulation. Lot of lime is used by leather industry for ternary purpose, and whatever effluents comes out of this industry, before it is allowed to flow into the rivers, some treatments, neutralization of treatment has to be given to these effluents, and then lime is used, and that lime can be reclaimed in the form of calcium sulphate from that effluent. That calcium sulphate can be used for the ternary and binary production of cementitious materials. This has been reported in this project. Now, pavement evaluation performance. 7 projects have been reported for the first time, 2 are ongoing, and overall 9 projects have been reported. First is road inventarization and pavement condition survey on the selected road stretches using vehicle mounted digital video imaging system. The objective is to prepare road inventory and pavement condition survey data for about 1200 kilometers length of national highway using automated road survey system and network survey vehicles. So far, data has been collected and it was prepared on as per RIS format of NHI, and whatever data has been collected and submitted to the NHI, this data now will be utilized for the road safety audit of these national highway stretches. Next reported is development of management system for maintenance, planning and budgeting of high-speed corridors. The objective of this project is to calibrate the SDM4 software for Indian conditions. It requires a lot of data related to pavement performance and geometrics of the pavements, and a time series data is being collected. We have already completed 2 series of data, and calibration of SDM4 is in progress, and 3rd series of data will be utilized to validate the calibrated model of SDM4. It is in progress. Next is application and performance evaluation of rain-of-fault preservative on 3 stretches of toll roads in Rajasthan and Gujarat states. 3 test sections have been laid on toll plazas, and it was observed that in 1 year, no significant difference have been observed in BBD, deflections, roughness and distress conditions of control as well as trial section. It is hoped that in the next 2 or 3 years, the difference of using rain-of-fault will be observed by performing the observations on control and test sections. But so far, no difference has been observed. Next is study on the performance of highways developed under KSTP in Kerala. Objective is to evaluate structural and functional performance to assess the socio-economic impact of upcoming highways in Kerala state. And it is expected that through this project, a comprehensive database on structural and functional performance of the state highways will be prepared, and deterioration models will also be prepared that will help for assessing the budget requirement for the maintenance of state highways in Kerala. Next is performance evaluation of core geotextile in rural roads of Kerala. Core geotextile has been used to lay the few test sections where strengthening of the weak soil was required, and it is expected that innovative design procedures for long-lasting rural roads will be prepared using core geotextiles for the strengthening of weak soils. Next reported is pavement performance studies on, it is also on core geotextile reinforcement in rural roads of Tamil Nadu. Objective is again the same, to study the performance of rural roads with subgrade reinforced by core geotextile, and it is expected that innovative design procedures will be developed which will be suitable for the soils which Tamil Nadu state have got, and your core geotextile will be used for the standing of weak subgrade soils. Then urban pavement management system for Tiruchirappalli city. This project have been undertaken to prepare a pavement management system for urban conditions. First it will be developed for the Tiruchirappalli city, and then the same can be utilized for assessing the need of maintenance and budget needs for other cities of the state. Points for discussion: PMB, CRMB and emulsion based warm mix asphalt mixes. Validation of flexible pavement design using accelerated pavement testing facilities. Reclaimed asphalt pavements. Use of geotextile for better performance of the pavements. Premature longitudinal cracking of concrete pavements. Development of pavement management systems. The organizations which have reported all these research projects are CSIR Central Road Research Institute, New Delhi, National Transportation Planning and Research Center, Thiruvananthapuram, Gujarat Engineering Research Institute, Vadodara, Maharashtra Engineering Research Institute, Nasik, National Institute of Technology, Tiruchirappalli, and Messrs. Gypsum Industries. That's all from my side. I hope next year we will be intensifying our R&D needs, and more projects will be upcoming in the area of pavement management, pavement engineering and materials, and particularly in the field of concrete pavements. Thank you very much.
Thank you, Mr. Vinod. As we observe that the presentation made by Shri Vinod Kumar has highlighted many issues and which are important in today's context. We are all, in all sectors, highway projects, we are facing problem of availability of the good quality aggregates. So, in the 12th plan, in the area of pavement engineering and materials, the one task for research, the researchers should flag how to save the aggregates. And we have to do more and more R&D, and R&D should not be R&D just for publication of the paper. R&D should lead to development of the technology, development of the design templates, development of the guidelines. And another issue is we have created a huge asset, and these asset has to be maintained. So pavement preservation is another issue, is another area where we should focus in the 12th plan, and we should work, we should find out the appropriate pavement preservation techniques. So here I urge researchers present here or not present here, we may convey to them that we should focus for a research which leads to a technology development which can be adopted by profession, particularly to save aggregate, to save pavement materials, and to save pavement preservation techniques and asset management. We will take up the discussion after all the four presentations. Now, next presentation is on a very important aspect, that is the geotechnical engineering, and in this area particularly I would like to flag the roads which can survive under natural disasters or other disasters. The next speaker is Shri P.S. Prasad. P.S. Prasad is working as senior scientist in Geotechnical Engineering Division of CSER Central Road Research Institute. He did his masters from Indian Institute of Science, Bangalore. The area of interest, his interest is utilization of waste materials, geotechnical applications, ground improvement, landslides, but he will make presentation on behalf of researchers working in the area of geotechnical engineering. I request Mr. Prasad to make a presentation, and he may take 15 minutes to make presentation.
Respected Chairman, Co-Chairman and Delegates, good morning. In Chapter 2 Geotechnical Engineering Division, the major 4 areas are covering, that is waste and marginal materials, soil stabilization, ground improvement techniques, and natural hazards and landslides. Here the first project, utilization of phosphogypsum in road works. Phosphogypsum is a waste, industrial waste generated from the fertilizer industry. The main objective is how to utilize this phosphogypsum for road and embankment construction. The phosphogypsum is having low density material when you compare it to maximum dry density, and the CBR value is very high, and the shear strength property is also very good compared with the local soil. The specifications have been prepared for heavy duty roads and rural roads. The main findings, phosphogypsum as such good enough for its use in different pavement layers. 7% of the phosphogypsum can be used in BM, DBM and HDBC mixes. 10% cement can be replaced by phosphogypsum in M40, M35, M30 and M25 concrete. For dry lane concrete, 10% cement can be replaced by phosphogypsum. Feasibility of cinder waste dumps for building and road construction. This cinder is a waste generated from the steel industry. This dump is nearly 70 years old and 45 meters high. The dump is a mixture of 80% of the cinder and 20% of the slag. The main objective, how to utilize the cinder waste for embankment and road construction, and next objective is how to reclaim the cinder waste dump. The cinder and slag are both having excellent geotechnical characteristics compared to the soil. So this material has the potential for the construction of the embankment. 40 to 60% of the cinder material can be used as a replacement of fine aggregates in sub-base and base material. But the main limitation, cinder is not feasible for bituminous layers of road pavement. Use of jarosite or jarofix in road works. Jarosite is a waste produced during zinc extraction. So zero site is mixed with 2% of lime and 10% of cement to stabilize the zero site mix. The annual production of zero fix is around 5 lakh metric tons. So these are the photographs showing the construction of test track near to Chittorgarh, Rajasthan. So the major findings: zero fix or zero fix soil mixes, zero fix bottom mass mixes have the potential for the construction of road embankment. The construction technology is similar to soil. First performance observations of zero fix embankment indicated a good riding surface. But the main limitation, zero fix is not economically feasible for subgrade construction. So development of non-nuclear density gauge for evaluation of dry density of compacted soils. The main principle is the variation of penetration resistance with the density. This equipment is very simple and compatible, but the thing is that it should be calibrated at the site. So development of the efficient non-nuclear gauges as a replacement of the nuclear gauges. So ongoing and completed projects. Feasibility study of the fine copper slag. So copper slag is the waste generated during the extraction of copper. So the annual production is around 2.5 lakh metric tons. So copper slag, the main conclusions are, it satisfies the MORTH and MORT criteria. Because it is a non-plastic material, the site covers are required. So about 15% of the fine copper slag can be used as a replacement of fine aggregates in DBM and BC mixes. Design of road embankments in creek areas of bush. The site conditions are very difficult and the standing water level is around 1.5 to 2 meters during full moon tide. So the design cross section here, geotextile is used as a suppression and geogrids are used for improving the bearing capacity, and soling we have given for a reducing the differential settlement. These are the photographs showing the construction of the embankment. Design of approach embankments of Signature Bridge across Yamuna River, Vajrabad, Delhi. Here the stagnated water level is 1.5 to 2 meters. Initially they have proposed to fill up this area with a sand, but getting sand is very difficult. So in this area, fly ash is used as a filling material in waterlogged areas. So this is the design cross section, and the embankment constructed successfully. During construction, floods have occurred and the embankment is stable even during floods. Use of coir geotextiles in road construction. The main objective is weak soil reinforced with coir mattings and HDB geotextiles. The future findings are lay test tracks and canal bank production using biodegradable geotextile material. The performance of the same will be monitored by providing geotextiles. The CBR value of the soil can be improved. Design of remedial measures at Lukbi slide. This is the slide is located at 26.8 kilometers on national highway. This is the lifeline for the Arunachal Pradesh, Sikkim state. So remedial measures have been designed. So the uphill slope stabilized with soil laying and shotcrete, and the downhill slope stabilized with 10 meters cantilever wall with a cladding and steel anchors. Site stabilization for platform at Diglipur, North Andaman. This site is located around 320 kilometers from the Port Blair. So in this area, around 3.5 lakh cubic meters of the material excavated to create a platform. But what they did, they have dumped the material very loosely without proper compaction. So it has created two slides. For stabilizing that slides, so these are the remedial measures suggested. Instrumentation and monitoring of Kalyasur landslide. This landslide is located in National Highway 58. So this landslide is almost stabilized up to 2010, but it has reactivated in the year July 2010 and again reactivated in the year 2012. So development of guidelines on management of landslides on Indian highways and roads. Total 8 chapters are there in these guidelines. So already 5 chapters are already circulated and remaining 3 chapters are under preparation. Effect of wheel loads on underground tunnels. The main objective to assess the wheel load stress acting over the pavement to study the effect of wheel load over the tunnel, to prepare a design chart for underground tunnel. The main conclusions: the effect of wheel load changes by various factors like height of soil, pavement thickness. Compared to the flexible pavement, the stress value is higher in case of rigid pavement conditions. The wheel load perpendicular to the direction of major axis of the tunnel induce almost double stress than parallel loading condition. Design and construction of base course and subgrade pavement layers with soil stabilized base course for lighter and durable highway crust. To assess the suitability of the soil stabilized layer with a nano polymer base soil tech MK3 for road and runway. Design of pavement cross section using soil tech MK3. Monitoring of performance of constructed road over period of time even during monsoon. The main conclusion: the optimum stabilizer content is 0.5 to 0.55%. The SSB layer in construction enhances the pavement life and also minimizes the maintenance cost of pavement. So these are the list of the ongoing and completed projects. The list of organizations reported: CSIR Central Road Research Institute, Indian Poly Roads Private Limited Gurgaon, National Institute of Technology Tiruchinapalli, National Transportation Planning and Research Center Thiruvananthapuram. The points for discussion: so utilization of waste material for road construction, importance of geotechnical investigation for road projects, use of geosynthetics in road works, adopting soil stabilization techniques. Thank you very much.
Thank you, Mr. Prasad, for making the brief presentation of the R&D work done in the area of geotechnical engineering, including soil stabilization, landslides and ground improvement. As we all know that we have enormous alternate resources which can be used as pavement materials, at least for construction of base courses, sub-base courses, etc. Only the challenge to the researchers is to develop technology out of R&D work and guidelines, specifications, so that this wealth, which is not waste, can be utilized in construction of the various pavement layers. We should aim in this 12th plan that we come up with effective utilization technologies using the waste materials in road construction. We have enormous loss, economic loss due to landslides, and we have done enough work, good work, to control the landslides, to investigate the landslides, and we should have some techniques where we can predict well in advance all natural disasters, and we should focus on those areas in 12th plan. We will take up discussion at the end of all the 4 presentations. Now I request Dr. Garg to make a presentation on the 3rd chapter of the journal report, that is on bridge engineering. Dr. Garg is a non-scientist, structural engineer working as senior principal scientist at Central Road Research Institute. He is doing pioneer work in the area of bridge monitoring, and he has published many research papers. Bridge engineering is very important area of R&D pertaining to road development. Bridges are integral part of roads, and health monitoring of the bridges is an area where we have to develop new techniques, easy methods, monitoring systems in the 12th plan, and researchers should focus on those areas. And now I request Dr. Rajiv Garg to make presentation.
Thank you, Mr. Chairman, Co-Chairman, experts, delegates, ladies and gentlemen. This section pertains to bridge engineering. There are 5 completed projects, 4 ongoing and 4 theses. The first one is related to the district diagnostic and rehabilitation of PSC girder bridges. These are the bridges which were typically constructed during 70s. This particular bridge was studied, and although it was a rehabilitation scheme, but I want to highlight this also, a very important point, that those two girder based bridges, the objective of this study was district diagnostic and suggesting the rehabilitation scheme. As one can observe that there were white cracks were observed, and it was found in conclusion that overloading is one of the main reason of cracking and its reduction in load carrying capacity. The strengthening using the external pre-stress was recommended. Next one reported was the assessment of noise and vibrations due to vehicular traffic on Munirika Bridge in Delhi. This is also a composite construction where the steel deck was constructed due to fast construction, and the RCC overlay the deck was constructed. This was constructed in 2009. This is a 3-lane bridge, and it is a continuous bridge of nearly 35 meters span each. The flyover is nearly 1.2 kilometer long. As one can observe that the bridge, the flyover is particularly in night, the traffic density increases, and the residents were feeling within say 200 or 250 meters, the residents were feeling very high level of noise and a high level of vibrations. Children were particularly affected, and it was reported in the paper that many of the infants were finding difficulty during feeding. I want to highlight the methodology that vibration sensors were utilized in form of acceleration and vibration velocity in all 3 directions. This was carried out on the flyover as well as on the buildings, and comparison was made, and the cause of and as well as remedial measures were suggested. It may be interesting to note that due to plying of heavy vehicles on the flyover, the residents in building were feeling very high noise levels, much higher than the Central Pollution Control Board recommendations. Similarly, the vibratory response were quite high, and several measures of remedial measures were suggested, which include the isolation of piers, starting from the foundation level of the piers, at least up to the 2.5 meters below the ground level, rubber pads were introduced, and sand was filled. This is one of the simple technique of isolation, and similar isolation was carried out on the edges of the roads, so that maximum reduction of possibility of vibration was ensured while reducing the vibration to buildings. Here it is very important aspect that serviceability aspects, particularly the displacement and vibration caused by the composite construction, we need more and more research and some more guidelines. Next project is about the structural health assessment and management of bridges. This includes 3 aspects, particularly the damage assessment using vibration mode analysis, effect of corrosion on RC structures, and fatigue remaining life assessment. The methodology was involved applying various sensors and techniques in a laboratory, and some more studies have to be carried out in field so that it could be ensured. The conclusions were quite important, that if there is a corroded bar, its area reduces, but still its ultimate strength also reduces to 44%. These things one should account in modeling while behavior of such structures. The next study is about the behavior of shear deficient beams strengthened by externally embedded reinforcement. This study was carried out on embedded reinforcement in laboratory, and one can note down that particularly for shear deficient beams, the inclined FRP sheets were put on the outside of the beam while creating the grooves, so that it is called the near surface methods, and one cannot even find what material has been put on the surfaces. The conclusions were very important, that strengthening of structures with near surface mounted FRP and steel reinforcement is an economical and feasible technique. Contribution of FRP for shear strengthening is comparable with the specimen having internal shear stirrups, and that is very important finding. But still there is some need of concrete guidelines and provisions in country. IRC as such doesn't cover at present, and then many of the engineers find it difficult to use. Next is about the mathematical modeling of repaired concrete structures. It highlights about the external pre-stressing technique strengthening, and in laboratory these studies were carried out. The important conclusions were that numerical model of flexural capacity of RC beams strengthened by external pre-stressing compared well with the experimental results. The external pre-stressing with trapezoidal tendon profile has performed better than that of deviated and straight tendon profiles in increasing flexural capacity, deflection recovery, and reducing deflection in post-strengthening stage. Further, that 10% loss of pre-stress was observed due to friction at deviation. This is important to note while carrying out the mathematical model. And I must say that external pre-stressing technique is a very powerful tool, and more studies are to be carried out so that prediction of such a study can be used directly by engineers. The ongoing projects are there. Development of structural health monitoring scheme for civil engineering infrastructure using smart sensing techniques. The methodology is simple, that they have used IMOD2 type of a node. A node is where the wireless sensing techniques are utilized, and they also have used the electromechanical impedance technique with piezo patches. The findings are still at laboratory stage, and these include the IMOD2 type and EMI for inspection and evaluation. Those are useful. Some more results are yet to come. Another is about the generating a facility or such equipments. For investigation of bridges, and particularly underneath and the deck, it is very difficult to reach those spots. Therefore, some type of mobile bridge inspection unit is to be created. With an aim of catering the needs of 2 and 3 lane bridges, this system has been created. This has been developed and is under testing studies. Next is about the study of corrosion susceptibility of steel reinforcement protected with anti-corrosive coatings treatments on ordinary and high performance concrete. The objective was particularly related to a comparison of uncoated and coated bars on HPC concrete. Everybody knows that coated bars perform well. However, when we carry out a mathematical model or while it's assessing the post-corroded behavior, such study plays very important role. The methodology was simple to apply a combination of HPC mixes in laboratory. Interim findings are there, but some numbers are not available, as can be expected that the performance of coated reinforcement is quite encouraging. Still some more results are to come so that it helps appropriate preparing the mathematical model. Another is about the creating a facility on complete range of independent facility of testing of expansion joints indigenously. To establish the complete testing facility, they have created a large number of testing facilities, including the raw material in form of chloroprene and steel It also involves the mechanical testing, cyclic motion test, debris expulsion test, pull-out test, opening movement vibration test, fatigue test, and seal push-out test. Testing modules for chloropine and H-beam has been carried out as per IS, IRC, German or American codes, and modules of expansion joint is under progress. This type of indigenous testing facility will certainly boost production of expansion joint of appropriate natures of our bridges. There are many themes of discussion, however, a few of them are listed here. Discharge diagnostic and rehabilitation of PSC girder bridges needs attention because a large number of such bridges are under stock of national and state highways. New techniques for structural health monitoring is always a need of our, so that quickly one knows the health of infrastructural stocks and appropriate measure can be taken in time. Development of toll of bridge management and their implementation is a much broader aspect where we start from inventorization to its repair stage, and such type of inventory or report of inspection of a bridge getting from somebody is a difficult task. Therefore, I urge on this platform that all the engineers and researchers come together and put efforts towards success of the bridge management system in India. Efficacy of strengthening and rehabilitation technique of bridges, assessment of noise and vibration induced by movement of heavy vehicular traffic on bridges, flyover, and their impact on nearby buildings. Although this type of phenomena has been observed, but more and more complaints are coming where that due to heavy traffic, the nearby residents are feeling more disturbed. There are certain guidelines on environmental assessment rules, codal provisions, but still how to implement them and assess the structures is an important need of our. The last one is about the indigenous development of mobile bridge inspection unit and other laboratories. There are a few theses reported about the development of techniques of in situ stress assessment in concrete structures, application of pushover analysis of RC bridges, experimental study of RC beams strengthened with CFRP fabric under pure torsion, analysis of anchorage zone stresses in post-tension girder bridges, effect of overweight vehicles on RCT girder bridges. I must request that many of the researchers and students do not report their results. It is requested that whenever such theses are complete, please send some information to IRC so that they collect and they are incorporated in road research. The list of organization includes these follows. Thank you very much.
Thank you, Mr. Garg, for a very nice presentation of the review of the road research work done in the area of bridge engineering. And I must congratulate the researchers who has developed indigenous bridge inspection mobile unit. It is a welcome step, and new techniques for health monitoring of the bridges are required so that we have good techniques to monitor the health of the bridges. And now I think we should break for tea, and next presentation, that is the fourth part of the journal report, fourth chapter of the journal report, that is on traffic and transportation including highway planning, design, management, performance, etc. We will take up at 11 a.m. after tea in the same hall. Now we break for tea and we will reassemble sharp at 11 a.m. for the next presentations. Thank you very much. Now the first presentation during this session will be on fourth chapter of journal report pertaining to road research work done in the area of traffic and transportation, including highway planning, design, management, performance evaluation, and instrumentation. Okay. And this presentation will be done by Dr. Ravi Shekhar. Dr. Ravi Shekhar, may I invite Dr. Ravi Shekhar? Dr. Ravi Shekhar is working as senior scientist in CSIR Central Road Research Institute. He has 12 years of research experience in the area of traffic and transportation engineering. He is PhD in the travel time reliability and transportation system. His recent interests are transportation planning, soft computing techniques in the application of transportation engineering. Now I request Dr. Ravi Shekhar to start his presentation, and he may take about 15 minutes.
Thank you, Chairman. Respected Chairman and Co-Chairman, and respected audience, and good morning to all, and welcome back to the second session. So, I am presenting on general report on road research in India for the year 2011 and 12 in the area of traffic and transportation engineering. So, the main in this area, the summary of the projects reported, particularly this traffic and transportation engineering are subcategorized as engineering, planning and management, and road safety and environment. Coming to planning and management, so completed projects and ongoing projects are about 8 projects are reported, and new projects completed and ongoing projects are 20 projects in this category. Coming to safety and environment, total 8 projects are ongoing and completed projects, and 7 projects are new projects are reported. So total 15 projects. Coming to the academic institutions which was reported in this report, in this section 4, are total 46, including master thesis as well as the PhD. So coming to, I will just summarize the reported projects in the area of the planning and management. So before that, I would like to discuss about the completed projects. In this category, 4 projects are reported, mainly travel time reliability based performance measures for evolution of sustainable transportation system, construction and development West Coast Canal in North Kerala, constraints in developing West Coast in Kerala phase 2, and study on stage carriage in Kerala. So coming to some of the projects which I would like to, the salient features of the completed projects are discussing here. First, the project, the title of the project, travel time related performance measure for evolution of sustainable transportation system. So in this, the object of this study is to identify the various performance measures and study the uncertainties of the travel time under the various influence of the factors which comes from the supply side as well as the demand side. So in this study, the identification is that, so like as compared with the normal traffic demand, how the travel time will be varies if the demand will be increased to 50%, and if the demand is reduced to 50% as compared to the normal demand. So it was identified that, so if the demand is increases 5.5 times, travel time is increased as compared to the free flow travel time. So if the demand will be reduced, it will be reduced to 2.3 times as compared to the free flow travel time. So similarly, this study also identified the supply side factors influence on travel time variation. So if the signal will fails in a for this study, it was identified, the study identified the urban arterial corridor in Delhi, a 2 kilometers length of the corridor, which was starting from the Apollo Hospital to the Badarpur border. So in this case, if the signal will fails, how this travel time will be affected. So it has been identified. In the average travel time, if the signal works is 17 minutes and signal fails, it will be 25 minutes. So coming to the another project, the salient features of completed projects, constraints in developing the West Coast Canal in Kerala as a phase 2. The object of this study is the study of the waterway navigability in a North Kerala and identification of the proposed waterway routes, identification of constraints of the cargo movement. The significant findings in this study are the use of waterway, if the waterways uses are reduced due to the construction of new bridges and also the roads, because the shift of the people from the waterways to the road. So this study is recommended further. The cargo potential of the waterway is to be studied as a strategy level study. So coming to the ongoing project, it was identified 4 projects: feasibility study and requirement of the pedestrian underpass vehicle between the Palanpur, Desa, Radhanpur section of NS14 and NS15, comprehensive traffic and transportation studies of the Goa, preparation of inventory of roads for the 2 black panchayats in Kannur district, and development of toolkit on analysis of urban traffic systems. So coming to, I would like to some silent features of the ongoing projects discussing here. The feasibility study on requirement of pedestrian underpass or vehicle underpass between Palanpur, Desa, Radhanpur section of NS14 and NS15. This study area falls in Gujarat state. The main significance of this study is to the accident prone locations, and mainly the accidents occurred in the morning times 9 a.m. to 8 a.m. to 12 noon. So in this study identified that the most of the accidents took place on the corridor because of the lack of at-grade facility as well as the mixed slow moving traffics on the main road. Coming to one more project, preparation of inventory of roads for 2 black panchayats in Kannur district. So the object of this study is to development of a authentical spatial database. So the approach they have considered is settlement level connectivity, total settlement, connectivity of unconnectivity of the village habitations to the network, road length required for the connectivity improvements. So the main significance in this study is to it was developed a database, authentic database for development of the further development of the district rural road plans as well as the core network plans, which will be useful for the PMGSY guidelines. So again coming to the newly taken up projects. So in this category 9 projects are reported. So these are the listed in this here. So I am discussing silent features of some of the projects in newly taken up projects which are completed recently. So the first project is the micro simulation based driving cycle in Delhi city for sustainable transportation system. The object of this study is to derive the driving cycle by considering the data from the on-ground real-world data and compared with the micro simulation tools to compare with the real-world data as well as the simulated data. So in this study, 9 urban arterial corridors have been considered in the Delhi road network, and particularly 2 categories of vehicles have been studied. So in this figure you can observe this one, the horizontal axis is time and the speed is the vertical axis. It has been compared with the micro simulated output as well as the raw data which was collected on the ground by using the V-box, velocity box data. So it is the main significance of this one. The collection of raw data is more expensive and time consuming. If you using the simulation tools, we can model the data, and further this model can be used in further studies to estimate the fuel consumption as well as the air pollution estimation. Coming to the next category, newly taken up projects, ongoing projects are listed, reported here. 11 projects that are listed here. Assessment of driving characteristics, driving effect on visual fatigue and blood pressure, traffic studies for junction improvement of major road corridors in Ahmedabad city, effect of headwear due to type of lead vehicle for urban road corridors, shortest path analysis for service area allocation for ambulance services. Another 4 projects also continue. Total 11 projects are in this category, reported in this category. So some of the projects are salient features of the projects are discussing here. So this is one of the projects, traffic studies for junction improvement of major road corridors in Ahmedabad. The object of this study is to estimate the future traffic for coming next 10 years, what is the traffic on a particular intersections. So in this study, total 34 intersections are identified, and it was distributed along the road network. So enter the urban road network of Ahmedabad city. So in this study, mainly the data has been collected and they are forecasted for the 10 years, and it was identified that which junction has to be prioritized, or improvements at grade improvement or grade separate improvements can be proposed. So in this study, it was identified that at grade facilities are required immediately for the 17 junctions, and 9 junctions to be required for another within year 2015, and 8 junctions are third priority to provision to be required grade separated facility. So in this study, the junction improvement drawings also been submitted. Coming to the driving effect on visual fatigue and blood pressure of the drivers, the object of this study is that to identify the visual fatigue of the driver and before entering into the on-stream road, and also the after driving, how the blood pressure and fatigue of the person has been estimated. So for this 15 drivers pilot based data has been collected, and also another 56 drivers have been collected in the entire project. The age group between these sample size is 26 years to 36 years. So it was identified that the BP as well as the visual fatigue of the driver have been value of this higher side, and the pre-trip are higher as compared to the post-trip. So coming to the part 2 as a safety and environment, in this category 4 projects are completed projects and 3 projects are ongoing projects. So one of the salient features of the ongoing projects discussing here, variability in vehicle fuel consumption under controlled conditions. The object of this study is to investigate the variability of the fuel consumption under steady speed conditions. So the study area has been discussed in the slide, and it was identified that the different steady speeds, 20 kilometers to 70 kilometers, have been considered. The vehicle will run along on the section in a steady speed of 20 kilometers, and the variance will be identified. It was identified that about 8% of the variability is there in fuel consumption for every steady speed, and it is also observed that the relationship between the fuel speed versus fuel consumption for various speeds are the polynomial, second order polynomial. So that was discussed here, the upcoming onward journey as well as the return journey. Coming to the newly taken up projects, completed projects are the 5 projects are completed in this category. So I am discussing here the salient features of newly taken up projects which was completed. The identification of accident prone locations and improvements measures the National Highway number 17 and 212 segments in Kozhikode district, Kerala. The object of this study is to collect the accident details pertaining to the past 4 years, analyze the accident and causative factors, various factors which was prone to the accidents, and carry out the micro level analysis of the accident prone locations. So the approach methodology is data collection, and analysis is carried out based on the quantum of accidents. In this study also estimated accident risk index. So the findings of this project is the accidents have been formed into groups which assigned scores based on the number of accidents. So the accidents have been categorized based on the quantum number of accidents, and considering the various parameters, the accidents have been given as a scoring. Coming to the newly taken up projects ongoing, so 3 projects are reported in this category. The first, one of the projects I am discussing here, which is the ongoing project, road safety audit of Dasway road network in Lavasa to comply the preconditions set by environmental impact assessment. So the object of this study is to conduct the road safety audit of the Dasway road network in Lavasa. This study suggests that this study has been done. Proposed methodology. This is an ongoing project. The findings are at to be reported, and the methodology adopted is that safety audit on existing roads monitoring means that what are the existing lacuna on the road network and the geometric features as well as the other influence factors. And coming to safety audit at the construction stage, during the construction stage, what are the problems which will be influence on the road safety? And coming to the safety audit and design stage, means the highway geometric elements and as well as horizontal element as well as vertical element and other cross-sectional details have been considered in the road safety audit of this project. Coming to the thesis dissertation works reported for the year of 2011 and 2012. I have categorized into the 4 different categories. Transportation planning related studies, 19 thesis works are reported in this category. In this category, the studies are mainly focused on land use and transportation planning, traffic assignment and dynamic traffic assignment, GIS-based bus stop locations identification, development of GIS-based framework to plan and monitor PMGIS guidelines. Coming to the next category, traffic engineering category, 20 thesis works are reported. In this, mainly the works are carried out reported on capacity analysis, road user cost studies, ITS applications in the traffic engineering, and congestion analysis in urban arterial corridors, and analysis of road accidents. Third category, advanced modeling techniques. In this category, 4 theses were identified and reported. Mainly these works are focused on fuzzy logic, which is a linguistic approach to model the behavior of the mode choice in a transportation planning related works, simulation of vehicle queuing at toll plaza, micro simulation based studies including the modeling heterogeneous traffic conditions which are really observed on daily and on Indian road network. The 4th category is vulnerable road user studies, mainly identified the 4 categories. Mainly focused in this study are facilities of pedestrians as well as the slow moving vehicles, and also the micro simulation based studies for the slow moving vehicles as well as the pedestrians' influence on and accident prone areas. Road safety with emphasis on non-motorized traffic. So various reporting organizations are listed in this category. Research works from academic as well as research institutes, CSR Central Road Research Institute, College of Engineering Trivandrum, IIT Madras, NIT Calicut, NIT Surathkal, NIT Tiruchirappalli, NIT Silchar, NIT Warangal, NIT Surat, Gujarat Engineering Research Institute Vadodara, Maharashtra Engineering Research Institute Nashik, National Transportation Planning and Research Center Thiruvananthapuram. Other reporting organizations are CSR CRRI, Central Road Research Institute, Infrastructure Kerala Limited, Ministry of Urban Development, Cosmos Fiberglass Limited Faridabad, Traffic Department Faridabad, Silos Engineering Private Limited Delhi, Department of Transportation Government of Kerala. So the main points to be discussed in this category, in this section are mainly first part transportation planning and management, assessment of driving, driver behavior, driver characteristics, driving characteristics, route network planning mainly on the transport road network planning, traffic assignment techniques also as well as the dynamic traffic assignment techniques, integration of public transportation system, multimodal transportation system in urban as well as the inter-corridors, comprehensive traffic and transportation studies, travel time related performance measures, urban speed management using ITS technologies, micro simulation based driving cycle and the behavior studies. Coming to the safety and environment, mainly focused on road safety and auditing, analysis of driver behavior and crash characteristics, measurement of air quality, noise level and variability in fuel consumption, micro level study of accident hazards on national highways, study of non-methane hydrocarbons such as propane and methane in the atmospheric environment, particularly the pollutions measured at idling conditions at the junctions. Like in the intersection, the most of the fuel consumption are observed, like CNG are observed, like propane at congestion intersections, any urban junctions, as well as the compared with the other uncongested intersections. That is the reporting salient features of my presentation. Thank you so much.
Thank you, Dr. Ravi Shekhar, for a very brief presentation of the research work done in India in the area of traffic engineering, transport planning. We all agree that the issue of accidents, road safety and health of the people due to effect of environmental pollution or noise pollution are some issues where society is concerned, which can be solved by sustainable transportation system and better auditing of safety issues on roads. Now the time is for discussion. I invite all the four speakers on road research in general report. They may come to the dais and then we can take up question answer from public. We may have question answer from the presentations. Apart from this, we may take up during the speakers may come to the dais, please. We may take up the issues which we want to flag for research in coming years during 12th plan. What is the need of highway sector for the research to be taken up by the researchers. Then after question answer session on general report road research, we will take up research presentations and then summing up of the session by co-chairman Shri Amla. So there is a question. I think I request the speaker. He may introduce. He may come to the mic. First speaker is R. Srinivasan, MD, KRDCL. He may come to the dais and read which question. Mr. R. Srinivasan. Is he here?
Sir, my question is it possible to lay the rigid pavement on the existing flexible pavement? If so, what is the procedure we have to follow? Shall we go for rigid pavement on the existing flexible pavement? If so, what is the procedure we have to adopt?
Yes, that is what we call white topping. And yes, IRC code is there, and we can lay a concrete overlay over existing white bituminous pavement. You have to see first the condition. If condition is very good, there is no need of any leveling layer of DLC. You can directly put your concrete pavement over existing bituminous pavement. If surface is distressed, some potholes are there, crackings are there, then a leveling layer may be required. First you put a leveling layer of DLC, minimum 7.5 centimeter, maximum 15 centimeter depending upon the traffic, and then you can go for concrete pavement construction over that.
Okay, thank you.
Now I invite Mr. Vikas Thakkar. Please come to the dais.
My question is to the speaker of chapter number 1. Sir, we are working in urban areas and a lot of wrap material is available. So I just wanted to know, based on the research project, what is the maximum amount of recycled asphalt pavement that can be used in the base courses like BM and DBM, and which mixed design guideline we should use for wrap in India?
Regarding the wrap, it is just beginning in this country. Wrap is being used extensively, rather it is mandatory in some of the countries, and it can be used varying from 10% to 50%. The quantity of wrap which can be used in DBM or BC mix depends upon the quality of the wrap. Quality in the sense, how much is the bitumen content in the existing wrap, what is the gradation of the aggregate, what is the stage of hardening of bitumen in the wrap. So wrap may be qualified into a active wrap and a non-active wrap. Active wrap can be used conveniently, maybe about 20%, 30% in DBM mix or BC mix, and non-active wrap can be used. It can also be used for in GSB and wet mix macadam layers.
Sure.
Now your next question is regarding the design of the wrap.
Yeah.
At present, the usage of wrap is very limited, and CSIR Central Road Research Institute is doing research, and maybe after 2 years completion of the project, we will be able to develop guidelines as well as a perfect design procedure. Rather, the technology to use wrap in DBM layers and BC layers.
Yeah.
But at present, we are designing wrap only by Marshall method of mixed design.
Okay.
But I think the design procedure for use of wrap should be a little bit different.
Sure.
And it should include some performance, because you are using the existing pavement material.
Yes.
Some performance criteria which we are trying to do.
Sure.
And maybe after 2 years on completion of the project,
Okay.
we will be able to develop perfect guidelines for usage as well as the design procedure to use wrap extensively in DBM and BC mixes.
Okay. So there was another question related to the, there's one project that was described, the accelerated pavement testing facility. So there were conclusions regarding the rutting model that is evaluated under this. There were 2 conclusions, but they were just related to the rutting model. I just wanted to know if the fatigue model, which is more more important in the flexible design, is it also considered, and what are the results of that fatigue model evaluation?
At present, the ongoing project pertains to only rutting model.
Okay.
But it is possible to do for fatigue model also. It is just beginning of the studies, so we will be doing in coming years.
Sir, the reason for this question is we have just come up with the new flexible design guide for 2012.
Yes.
So how relevant are the results that are done under this to that guide?
Actually, new IRC 37 is based on mechanistic analysis, and at present we are doing validation of only old IRC 37.
Okay.
So we will take up, it is just released yesterday only.
Sure.
So we will take up study to validate new IRC 37 also.
Sure.
DST has sponsored a project, and we are having lot of projects funded by Planning Commission in 12th plan.
Okay.
So we will come up with.
Sure. Just one last question. There was also mention of the warm mix technology that is evaluated. Just wanted to know if there are any guidelines for the mixing and laying temperatures to use warm mix in India right now.
Not presently. In India, the warm mix technology is at a developmental stage, and there are 2 types of warm mix technology. One is additive based.
Sure.
The other is half warm mix technology, where the aggregate is half warmed and binders are emulsions or formed bitumen.
Sure.
So, as far as where the binders are emulsion and formed bitumen, CSIR Central Road Research Institute executed a project as shown in the general report, where the temperature of aggregate is about 100, and the temperature of emulsion is about 75, and laying temperature is 84 degrees centigrade. So, and bituminous concrete on a national highway has been laid successfully using the hot mix plant switching off the, not switching off, but changing the heating system to lower temperatures. The other technology is additive based, where there are mixed results. There are various additives. These additives are mainly surfactants, which either reduce the viscosity of the binder at higher temperature, and there are some other type of warm mix technologies are also there, but the economy of a warm mix technology is not there. If the reduction in temperature, laying temperature is less than 25 degrees centigrade. So the conclusion is this: at least 25 degree centigrade reduction should be there. But still there are not IRC guidelines on this issue, and these guidelines are really required because the future of this technology, warm mix technology, is very good in India, and it is required to reduce the emissions. And in some areas, the lead between the hot mix plant and laying site is very long. And if the mix is brought from 50 km or 60 km, is cooled down, and you cannot achieve the density of the mix. And if you don't achieve the density of the mix, there are a lot of voids, and that leads to percolation of water, and ultimately the damage of the surface due to stripping and loss of adhesion. So guidelines are required, and I think IRC should be working on framing the guidelines.
Thank you.